All right, today we're going to look at another advanced topic, partial fractions. It's another way, another technique to integrate by breaking down rational functions into things that we can integrate. This one right here, we can't. Our typical reaction would be to do a u substitution with the denominator here, but we can see that 2x minus 2 is not our numerator, so that doesn't match our any pattern that we have. Um, we could think of maybe arc tangent, inverse tangent, but that's not going to work out either. What we need to do is the very first thing is to factor our denominator. So we'd get x, and then let's see, minus 3 and plus 1. These would have to be if this rational function was made up of um, two other rational functions, these would have to be the denominators. And they would be proper, and so this is first degree, our numerator would then have to be constant. And we just need to figure out what a and b are. Well, we do that by multiplying by our least common denominator, which in this case is x plus 1, x minus 3. And I know that's slightly improper notation, but we're going to distribute to all three of these. And so we get 5x minus 3 equals, because the whole denominator gets canceled there. Here, just the x plus 1 gets canceled, so we get a times what's left, which is x minus 3, plus b times, now the x minus 3's cancel, and we get x plus 1. Okay, if we simplify this just a little bit, we see we get ax minus 3a plus bx plus b. Now, what we're going to do is we're trying to find two unknowns, right? A and b. So we need two different equations. So we're going to get those two equations by looking at the coefficients of the variables. So we're going to start with looking at just x. So on the left here we have 5, and then we have a. So we have 5, we have a, and we have b. So a plus b has to equal 5 for this equation to be true. Then we'll look at our constants. I like to use x to the 0 for constant. We have negative 3 on the left and minus 3a plus b on the right. Now we've got a system of two variables, two equations. I'm going to subtract the top from the bottom, or the bottom from the top, however that's worded correctly. 5 minus negative 3 becomes 8. A minus negative 3 becomes 4a. B minus b becomes 0. So this implies that a is 2. I'm going to use the one without negative signs to get b. You get 5 equals 2 plus b. Here's where I substituted that in. So b equals 3. So we can take this rational expression, break it down into what are called partial fractions, and we get 2 over x plus 1 plus 3 over x minus 3. Now, if you look at this, these are easy things to actually integrate. We could integrate and we would just get natural log. We get 2 natural log of x plus 1 and 3 natural log of x minus 3. So that's our end goal. But there's a lot of little things we got to look at too. There's not a lot. There's some little things we need to look at for partial fractions. And that's what we're going to do. We're going to hit several examples, as many as we can. Might have a second video on as we get a little bit into the more complicated ones, but we'll see how far we can get on just this one video. So this is your basic example where you have just two terms. Here we have two terms, but they're the same. They're repeated. And so we handle that slightly differently. We're still going to have an x plus 2 term. The other option that we would have would be an x plus 2 squared term. Okay, those are the only options we would have for denominators. So again, we're going to multiply. We're going to multiply by our x plus 2 squared denominator. least common denominator. And when we multiply across, we get 6x plus 7, a times x plus 2. And this time, this whole denominator gets canceled as well, and so we just have b. If we look at the x's, the coefficients, we get 6 equals a. So that's done. The constants, we would have 7 equals, now we're going to distribute that a, so we get 2a plus b. Well, we need to substitute in. 7 equals 12 plus b, so b is -5. So this becomes, let's see, a was 6 over x plus 2 minus 5 over x plus 2 squared. So I like these to start out with. They're a little puzzle that you get to figure out and break it down. It's not something you normally do, or you don't do very often. And so they're fun for a while. If you have to do too many of them, they start to become monotonous and a drag. The algebra can start to get quite complicated. Well, not complicated, as more tedious. All right, so if we look at this next one, it's an improper fraction. We have x cubed over x squared, so third degree over second degree. So we will need to do some long division. Yeah, I can hear all y'all moaning right now. It's okay. Remember, we're going to take the bottom. We're going to do x squared minus 2x minus 3. Then we're going to put up our division, old school long division sign here. We have 2 cubed minus 4x squared minus x minus 3. Cube. So we're not missing any terms, so we didn't have to put in 0. So x squared times something is 2x cubed. That's going to be a 2x. I like to keep everything lined up, so here are my linear terms. 2x times this, it will be 2x cubed minus, let's see, 4x squared minus 6x. We're going to subtract this. So 2x cubed minus 2x cubed is 0. Negative 4x squared minus negative 4x squared is 0. Negative x minus negative 6x, so that's negative x plus 6 is 5x minus 3. There's nothing we can multiply by x squared to get 5x that is not a fraction. So we're left with this over our this over here. So we end up with 2x, that's our quotient here, goes here, plus our remainder, 5x minus 3, all over our quotient, dividend divided by divisor, our divisor, x squared minus 2x minus 3. Well, this was example 1. So this improper fraction becomes 2x plus what we had up there, 2 over x plus 1 plus 3 over x minus 3. So you would have to do what we did on number 1 to this, but we've already done it, so I'm just going to show you that. So again, these would be easy to integrate. X squared is easy to, or 2x is easy to integrate. It'd be x squared. So that's the goal with this, is that we break it down and then be able to integrate. All right, so 3 more examples here, and you will have enough to work with. Again, these are we're just touching the basics of this technique, allowing you to get started with it, so that you're more familiar with it when you get to it in Calculus 2. So we have negative 2x plus 4 over x squared plus 1, x minus 1 squared. So we know how to handle the repeated factor. This can't be broken down anymore. It's a sum of squares, not a difference of squares. So it's slightly different. This was linear, this is quadratic. So when we have a quadratic, what's called an irreducible quadratic factor, we have to use, now remember, it can be a proper fraction, so this is second degree, this can be a first degree, so this would be ax plus b. And then we get our c over x minus 1 and d over x minus 1 squared. So now when we multiply this out, we get negative 2x plus 4 equals ax plus b times, okay, so this is going to cancel out. We're left with x minus 1 squared plus c times one of these gets canceled out, so we get x squared plus 1 times x minus 1, only one of them there, plus d times, now that x minus 1 squared cancels out, and we're left with x squared plus 1. Well, let's do a little bit of foiling here. We have x squared minus 2x plus 1. This would be, oh goodness, x cubed minus x squared plus x minus 1. And these others aren't too bad to distribute. I'm going to go ahead and write it out so I can mark it up as I simplify. So negative 2x plus 4 equals ax cubed. So I'm taking ax and multiplying it through this. Minus 2ax squared plus ax. Now I'm going to take b, multiply it through, plus bx squared minus 2bx plus b. Now I'm going to take c and just multiply it through. That one's easy. That's plus cx cubed minus cx squared plus cx minus c. And then last one here is dx squared plus d. Whew, that's a lot. So we got four unknowns, so we need 4 equations. Well, we've got our 4 variables, so we'll start with x cubed, x squared, x, and our constants. So we'll set up these equations. Let's see here. On the left, we have 0 for both the cubed and the quadratic on the left. On the right, we have a cubed here and a cubed here. So this is a plus c. For the x squareds, we have 1 there, 1 there, c, and a d. Ooh, that's fun. Negative 2a plus b minus c plus d. Then x, we do have a number on this side, so negative 2 equals, x's are here, here, here. Okay, so that's a little bit easier. A minus 2b plus c. And then our constants are 4 equals b minus c plus d. All right, so we've got four equations here. I'm going to label them just from top down, 1, 2, 3, and 4, so I can say what we combine here. Let's look at something easy. I see b minus c plus d, b minus c plus d. So those are going to combine real easily. So let's go ahead and do that. Let's do 4 minus 2. So that's going to be the 4th equation minus the 2nd equation. So 4 minus 0 is 4. There's no a here, so 0 minus negative 2 is 2a. Then b minus b is gone, negative c minus negative c is gone, d minus d is gone. So that tells us that a is 2. Well, that's good. We already got one down. So with that, then let's use equation 1 to get c. And we get 0 equals 2 plus c, so c is negative 2. And then what can we do? We look at, I think it's just plugging in now, if I see this correctly. 3 is negative 2 equals 2 minus 2b plus c. So that tells us that b equals 1. And 4 would be 4 equals 1 minus negative 2 plus d, which implies that d equals 1.